Thank you all for coming. So my name is Daniel Caixinha, as Michal said, and I will be giving you a whirlwind tour of testing in Elixir. So I'm a software engineer at Onfido, where we do identity verification remotely and at scale, and we've been using Elixir in production for the past few years. So this is my contact information. You can find me pretty much anywhere except for Facebook, Twitter, Instagram, or LinkedIn. But so let's start with the motivation for this talk. Nowadays, we are all aware of the importance of having great test suites, and they are an integral part of any application. And so we create these suites to deploy our code with confidence and make sure that we are not introducing regressions with each feature that we are having. But on the other hand, carelessly built test suites will slow you down. So if you don't take time to think it through and plan your test suite, eventually you will be starting to wonder why are you maintaining this in the first place. So that's what we are trying to avoid with this talk. And moreover, redundant coverage will kill the morale of your team. So in the chaos theory, there's this concept of the butterfly effect, which states that the flap of the wings of a butterfly in Brazil will manifest itself as a tornado in Texas. So the analogy to testing is that sometimes you change one source file and you change the corresponding test, and then you run the whole suite and you break like 1,000 tests. So it's like a seemingly innocuous change will just break all of your tests, and that's due to redundant coverage because you have a lot of tests that are indirectly depending on some module. So testing isn't just about catching bugs, although it's one of the main motivations for testing. I also feel that it's a great source of living documentation, so it will help newcomers to a project get a hold of it and know what it should be doing. And also they are a great source of design feedback. So if you have some trouble testing something, you should take that feedback and probably improve the API of your live modules instead of trying to fix your test. Yeah, I think different types of testing complement each other. So property-based testing has been having a lot of hype lately. And yeah, a case in point for this is that just the last talk in this stage was about it. But I'm not here to bash on property-based tests. I think they are very useful, and I want to explore them further. But I think they complement each other, and they can live side by side. And I think there's a lot of value in doing so. And lastly, hopefully this talk will help the community build better and more maintainable test suites. So here's the very famous testing pyramids. Just in case you aren't familiar with it, basically the width of the pyramids tells you how much tests you should have of that type. And as you move up the pyramid, the more integrated the tests are. So you begin by the unit tests, which are ideally isolated, and you should have a lot of those, and then less service level or component tests, and a few end-to-end tests. And I feel that I derive a lot of value from following this structure in my test suites, and I usually start by having two test suites. One that's sitting as low in the pyramid as I can get, so I have a lot of isolated and decoupled unit tests, and then I create a second test suite that's as integrated as I can get. And I usually only have a few of those, the ones enough to give me confidence when deploying my application. So basically, the unit tests will test the business logic, the branching logic in my applications, and then the end-to-end tests will test that everything is plugged together as it should. But a better depiction of what I found in the wild or even created myself is more like this. So you have some unit tests that use mocks and some that don't, and then you have some integration tests that then don't run the live things, the live modules, and also use mocks in some way. So it's a lot hard to work in such a code base because you just spend so much time figuring out what is happening and what should be happening. Yeah, eventually you spend a lot of time when you try to debug something and find the root cause in a suite such as this one. So hopefully we can avoid, after this talk, we can avoid ending up in this situation. So we'll begin by the lowest level, the unit tests. before beginning, there's some universal rules I'd like to discuss. So these were defined by Michael Feathers some 14 years ago. Yeah, he said that a unit test is not a unit test if it talks to the database, if it communicates across the network, if it touches the file system, if you can't run it at the same time as any of your other unit tests, or if you have to do special things in your environment to run them. And I think in Elixir, this point is particularly important. So XUnit gives us this way of running all of our tests concurrently. When you can't do so, you should really stop and think about it, because if you can't run a unit test concurrently, it means that probably it's depending on some global states or some shared module or some global behavior. So when you hit such a case, you should just stop and check if that test should move to an integration level test or if it should change your tests. Before jumping into the tests themselves, I would like just to briefly talk about these two TDD schools. So Elixir has changed my way and how I approach testing. Usually, I used to lean more towards the London School TDD. I will just give a brief run through. So Detroit School TDD is the one created by Kent Beck. It's also known as the classical one for that reason. And then we have London School TDD, which was created by Steve Freeman and Nat Price. And the difference between these two schools is that in the classical one, you create as few mocks as possible, so the ones necessary. So, for instance, when you are contacting a database or communicating across the network, and the end goal is to maximize the safety nets provided by your test suite. Whereas in the London School TDD, you mock every interaction with the subject under test. So every collaborator that you have, you'll create a mock for it. And coming from the Ruby community, I would use more this type of TDD, where I would mock every collaboration that my subject under test has. Coming to Elixir, I kind of reconsider this approach, because in functional languages we tend to strive towards like pure functions and functions that are free of side effects. So it doesn't make sense to create mocks for every collaborator. And I kind of think that I stopped being so religious about this. So I kind of create mocks when I need to. As I've said, I come from the Ruby community, so naturally Sandy Metz was a big influence of mine. And in her talk, The Magic Tricks of Testing, she comes up with this matrix, which she called the unit testing minimalist. So this matrix, if you follow this matrix, you will end up with maintainable tests, because you will avoid redundant coverage, because you'll just create the right kinds of testing. She breaks down this matrix by the type, so either queries or commands, and then the origin of the message that's coming through, so either incoming, sent to self, or outgoing. So query is something that doesn't change the state of the system and doesn't have side effects and returns a value back. And the command, on the other hand, is something that changes the state of the system and may or may not return something back. According to this matrix, messages that are sent to self should just be ignored, as they will implicitly be tested by the other types of testing. Even if you don't come from the Ruby community, I highly encourage this talk, because the points that she makes are very universal. So we'll be beginning by the incoming query, so in which case we should assert on the result that's coming back to you from the function you are testing. This is a module that is an address validator, so we'll be testing this module as we go through the talk. For now, we'll focus on this function. This is the validate function that takes an address, which is a string, and determines if it is valid or not by looking at the length of the string. So if it's lower than 32 characters, it's valid, and it's not valid otherwise. So how would we test it in Elixir? We can have two cases, one for a valid and an invalid address, and these are very straightforward, I guess, because you can just run the function that you are testing and then pattern match on the return value that you are expecting. So if it is a valid address, you pattern match on true. When it is an invalid address, you pattern match on false. So nothing to explore further here. This is the simplest case. moving on to the second type, which is the incoming command, in which case we should assert on the direct public side effects of running that command. So for now, we'll be focusing on these two functions. So the command itself is the set validation level one, where we are using the application config to store this validation level. So it would be something like either strict or loose, or it would define the strictness of the validation for this module. And yeah, testing this function, we'll do something like, so we first set the validation level, so we run the function that we are testing, and then we observe the public side effects of running such command. In this case, we know that the validation level is the same that we provided beforehand. And just a note here, so since this is an incoming command, you should not expect to call the application.putenv module, as first of all, that's leaking the implementation details of your subject, and also you just want to observe the public side effects, not match on a specific message. That's what we should do on the next. That's what we should do on the next type of command, which is the outgoing command. In this case, we should expect to send a message and expect that we do so with the right arguments. So let's look at how we would test this in Elixir. So now we are in this module, we are focused on this part. So in the validate function, we call this emit event function with the event, and then we are calling here below, we are calling the event emitter module with the event description that we passed from above. And how would we test this in Elixir? First of all, we need to use dependency injection. So we inject the dependency so that we can then provide a different one depending on the environment that we are running in. So we are now fetching the event emitter module from the application config. So in the normal config, so config.exs, we inject the real event emitter, so the live one, and then in test we inject the event emitter mock, which is what we will see now. So this module, the simplest case would be we will implement this emit function, which is the one we are creating the mock for, and then we are pattern matching on the address validated argument. So indirectly, we are testing that this function is being called with the right arguments because we are pattern matching on it. And once this function gets called, we are sending a message to self. So we are sending a message to our own process with this atom. Then in the test codes, we can just do this. We call subject.validate, so the function we are testing, and then we verify that the side effect is being produced because we are using assert received to know that we received that message. This is a nice approach, and at onFIDO we got away with this type of testing for very long, but it has some issues. The main one is that over time the mock may or certainly will diverge from the real thing, the real module, and this may put you in a state where you run your test suits and everything is green, you deploy it and everything starts to be on fire in production. So how can we avoid this? Because basically the issue is that the mock and the real thing diverged, and we solved this by starting to use the mocks library. So this is a library created by José Valim 2 years ago, and this is the implementation of the testing philosophy outlined in this blog post, which was written like 4 years ago or something, which was quite long ago. But I highly recommend this blog post as it explains the philosophy behind testing in this library. So how would we test this same thing? So the event emitter module with mocks. So first of all, we add mocks as a dependency, and then in the test helper, we are making this call, the mocks.defmock, where we are passing in the name of the mock module, and then we provide this for clause where we say that this mock that we are defining is a mock for this live module, and then mocks will behind the scenes verify that those have a compatible interface, they have the same interface, and and that's so they can never drift away because your test would break in such a case. Just a note, you need to have, so this is powered by behaviors, so the Elixir construct behavior, and you need to add behaviors to the things that you want to mock so that you define this explicit contract, and then your mocks can verify that contract. Then on the test itself, we just need to import mocks, call this setup verify on exits, just so that the expectations in this test are verified when the test ends, and then the expectation in itself is inlined in the test. So we can say that the event we expect the emitter mock to receive an emit function call, and we pattern match on the argument, so validated address. And when that happens, we just return the atom OK, which is what the real module does. And an important point is that at the top, you can see that we are still running our tests with async true. So this test is still running in parallel, which is kind of important, as it allows you to have snappy feedback cycles as all your tests run concurrently. And there's some other ways of creating mocks in Elixir. There's a mock library and the Mac Erlang library. But yeah, those change the global reference to that module that you are creating the mock for. So because they are doing that global behavior change, you cannot run your tests concurrently. So if you use those libraries, you need to stop running your tests concurrently. So before wrapping up the unit test level, just two testing principles that I've been following and I found really helpful. The first one is don't mock what you don't own. So this is very famous, especially in the London School TDD. And I guess this phrase is a bit counterintuitive because you want to create mocks for the things that you don't own so that you can control their behavior, right? But what this phrase is really saying, I will show with an example so it becomes clearer. So imagine that we have a certain application, our app, which uses the X-Twitter library to communicate to Twitter and do something. So what this phrase is saying is that you shouldn't mock directly the X-Twitter library. What we should do instead is create a wrapper for this dependency, and then we would create the mock for our wrapper, because X-Twitter is outside of our domain, is outside of the domain of our application, whereas this wrapper is defining the contract that the dependency that we have with this library, and we can mock that safely and not the library itself. And that's what the mocks library is enforcing, because, for instance, if X-Twitter would not provide the behaviors, you could not use mocks on it, so you would need to create this interface for the library. The second principle is damp, not dry. So this principle, this means descriptive and meaningful phrases and not don't repeat yourself. So it's defending that we should not be smart in our tests and try to remove all the duplication, and we should rather instead have descriptive and meaningful phrases. So just a very quick example. Imagine we have these two test cases. So we can see that there's some duplication here. So we know that the setup is repeated. When the address was already validated, then do this or then do that. And we would spot this duplication. And for instance, in Ruby, we would spot this and move this to an outer context. So when the address was already validated, and then have two inner contexts in that. But actually, in XUnit, you cannot do this. So this is a design decision by the Elixir core team. And the end goal is that you should be able, just by looking at a test, you should be able to know what it's doing and what are the expectations on it. And when we have a highly nested set of context to go through, you start to really lose a lot of time just figuring out what's happening. So although this leads to some duplication, your future self, I guess, will thank you if you do this, because you can just know what you should be expecting for this test. So I finished with the unit level test. Let's move up the pyramid, go through the service level test now. So usually I was a bit skeptical to create this kind of tests. As I've told you in the beginning, I would create just two suites, one on the lowest level and one on the end-to-end level, or as close as I can get. And I would never create tests of this kind. But as we'll see throughout the talk, my approach has changed regarding this, and mainly because at Onfido we are moving towards microservices-oriented architecture. So it becomes very hard to maintain end-to-end tests. So we are now using a lot of service or component level tests. So imagine that we are testing this microservice that's in the middle, our microservice, and this has a bunch of dependencies downstream. So microservice X, Y, etc. What we are doing in this kind of tests is so we create a mock web server for these microservices that are our dependencies, and then we verify that. So we create this mock web server that will return a pre-baked response that we define, and then we verify that our whole application, so end-to-end within our microservice, works as expected. Since this is creating an actual web server, we are actually running the live clients. So all the HTTP communication is going through and back. So it's almost like end-to-end tests, but for our microservice. They are not true end-to-end tests because we are using Phoenix helpers to make the HTTP call. So we pass some of the initial routing shenanigans, but it's almost true end-to-end tests for our application. For this, we are using this bypass library, which allows us to create these mock web servers. Let's see how we can create one test of this type. So first, we add a bypass as a dependency. Then in the test helper, we ensure that the bypass OTP application has started, and this is then the test itself. First of all, in the setup block, we call bypass.open, which will start the actual mock web server, and then we pass it as a context to the tests. And first of all, we call this bypass.expect function, which will set our mock expectations for this microservice. So we can say that when there's a GET request to microservice X API some endpoint, we'll return this baked response, in this case 200 with body status and valid true, status okay, valid true. Then we actually contact our own API, so we make a request to our own API and then validate that we got the response back, which the response that we were expecting. Indirectly, we are testing that it went all the way through, got this response back, and then return the response to us. Over time, the mock may or will diverge from the real thing. So this is exactly the same problem as we've seen in the unit test level. At Onfido, we solved this by starting to use contract testing. So we are using this library called Pact Elixir. It's still in a kind of beta stage, but it has been working quite well for us. So shout out to the maintainers of this library. And so I'll just go through a quick rundown on Pact. So Pact is a consumer-driven contract testing framework, and what this means is that you never need to lift up both the consumer and the provider of a certain interaction, and you can do so asynchronously. So and that's being handled by the Pact broker that's here in the middle. Let's go through the flow. So the first step is that our microservice will run a test against this Pact mock server. So let's see this first interaction. This is an example of a contract test. First of all, in the setup, we start the Pact mock server, which will be again a mock HTTP server, web server. And first of all, we call this new service provider. So within Pact, there's this Pact defines interactions between a consumer and the provider of that service, and that's what will actually define the contract that a consumer expects from a certain provider. So looking at this function, we say that for provider service X and consumer demo, which is our microservice, we add this interaction. So when we are checking that the address is valid, when there's this request with this GET request to this path, the server will respond with this status code and with this body. And yeah, this will define the interaction. And then in the test itself, we contact the Pact mock server, and then we just assert that we got the expected response back. And the last line we call the write Pact file. So this line will write a JSON file with all the metadata surrounding this interaction. So this is the second step. So Pact mock server will then upload to Pact broker this JSON file, which has this structure. So it has, I've truncated the file. It has some more metadata, but you can see that we are like for consumer demo and provider service tags. We have this set of interactions, which for now is a list with only one element. So this will then be uploaded to Pact broker, and the Pact broker will save this. So this will be the expectation that the consumer has on against this provider. Then I won't go through this, but in our case at Onfido, whenever there's a CI build for Service X, Pact will take care of run the unit tests for that for unit or integration level tests for that microservice X, and check that the output that it got is still respecting the contract that its consumers are depending upon, and hopefully the test will fail if it's not. So we are done with the service level tests, so we are going through to the last level, the end-to-end tests. And honestly, I don't have much opinions to share with you because we are moving away from such tests. We used to have a lot of Cucumber tests, so in the old monolith, we would have a lot of Cucumber tests that would have true end-to-end tests using our API, and it gets quite unmaintainable because like when you have such a test, for instance, in our case, we have the user service, and you need to create a user. Then you got the user, but then you need to create a report. Then you create a report, and there's a lot of baggage that goes into each test, and it gets unmaintainable quite quickly. So the approach that we move towards is focusing only on our microservice, and yeah, we migrated a lot of the end-to-end tests to service level tests. And whenever my team is making a change to this microservice, we can focus on only our tests and our test suite, and not depend upon like the end-to-end tests that depend on a lot of teams. Yeah, this was even worse because we needed to use images and videos. So we would develop a certain feature quite quickly, but then most of the time was spent like trying to get Cucumber tests to work because we needed an image that would yield a certain behavior for the system, and now we don't need to do that because we have this mock, the service level tests with the mocks that we want. So just for reference, I haven't used this myself, but have heard many good things about these two libraries. Hound and Wallaby, they allow you to create browser-based tests, so having end-to-end tests. I didn't explore them as I told you, but it's just for you to explore if you have the needs. So where does this leave us? I've been talking about this whole approach, and this is the output of running the two test suites that we now have. This is in the application that's most actively developed in Onfido, and we have two suites. One that on the top is the unit test one, where we have 826 tests running in 6 seconds or so, and then we have the service level test where we have like almost 200 tests in 28 seconds. So we have this really snappy, for me, feedback cycle, because we can deploy within like a minute or so, not a minute because then we have to deploy the deploy itself, but we can have the feedback that we need to deploy with confidence in a very short amount of time, which wasn't the case in the end-to-end tests. So yeah, this has been working quite well for us, and honestly, I don't recall the last time that our team has introduced regressions, and hopefully that's not because I have Alzheimer's. So wrapping up my talk, tests are not just about regression safety, so they are very important, but also try to take the design that tests give you into account. So sometimes trouble testing something is solved by changing your production code and not the test code. Write your tests as simple and straightforward as possible. Again, follow the damp not rise principle, and your future self will thank you. When creating mocks, do so based on behaviors, as that will avoid the funny situation when your tests are passing but production is on fire. And explore different kinds of testing, and then pick the ones that are right for your context. Like depending on the maturity of your team and the size, different kinds of testing will appeal to you. So, for instance, 2 or 3 years ago, it wouldn't make sense to have this investment on all of this contract testing and setting it all up, because we were a smaller team and we can just could just communicate. But now that we are growing, this no longer works, and you need to evaluate where you are in this spectrum. And yeah, so just before wrapping up, 2 very quick shameless plugs. So me and my colleague Andre Albuquerque wrote this book, Mastering Elixir. We were able to convince our editor to have a whole chapter on testing, which we wisely named Find Zen Through Testing. And we create a Dropbox-like application throughout the book, written in Elixir, obviously. Yeah, check it out if you'd like. Also, I'm organizing the Lisbon Elixir meetup. So we have been having monthly editions for quite some time now. And if you are ever in Lisbon or you want to attend or even give a talk, reach out to me, and we'd love to have you. So thank you for your time, and I'm open for questions.
Hello, and thank you for your talk. It was very interesting. So my question is, you have told us that we shouldn't test the code we don't own. We shouldn't mock, the libraries we don't own, but instead we should wrap them into something we actually own. How do you test that your wrapper is correct?
Yeah, that's a great question. We are not doing this at Onfido, but what I see being done, and I think that's what makes most sense, is in those tests you actually run. It's like an integration test where you are running from the wrapper onwards, and you are actually contacting your dependency and making sure it works. Then you can tag it as like an integration test, and you only run those, like, you don't run them as part of your normal suite, but you run those every once in a while or something.
Hey, thanks for your talk. How would you test distillery release?
Sorry, the?
Distillery release.
Oh.
If you're not doing end-to-end?
So we are doing end-to-end tests, but before packaging up the release. So I guess that's the responsibility of the distillery maintainers themselves, testing distillery. But maybe I'm not getting the question.
No, because before you deploy, you package your application as a distillery release, like an OTP release.
Yeah. And
then if you don't do end-to-end tests, you're not sure that your deployed release is going to work, or that your Ecto migrations ran. Or...
Yeah, we are testing, we package the release, and these service level tests run against that. But yeah, we don't test that the migration runs successfully. That's a good point. So these are not like fully fledged tests in that sense. There's some part that you are missing, that we are missing. But yeah, that's a good point. I don't know how I would test that.
Thank you for the talk. Speaking about the mocks, when you started to say that we should test, we should like create wrappers for the tests and use mocks for making upon behaviors, like make wrappers on the behaviors, not using like mock or so we can run our tests asynchronously. How would you handle that? You need different kind of mocks to test different kind of scenarios.
What do you mean by different kind of mocks?
All right, if I want to create a mock for repositories that has a get function, and I want to make sure that at one point of time, when I get some result, I transform it in some way, but in another test that I want this mock to throw an exception, and I want to test how this is handled through my service.
Yeah, so first of all, I wouldn't mock a repo, but that's another discussion. But mocks allow you to define different expectations. So you can have in one test block that you expect repo to have gets and do like return a normal result, and then in another test you can have that expectation block that I've shown. And when the lambda gets called in the body of the lambda, you can raise something back. So you can do whatever you want because you can just change the lambda there. Cool.
Okay, I think that's it for the questions. So thank you, Daniel.
Cool. Thank you.
And yeah.